Cool. Right, let's kick off another session of this zero-to-quake-3 project where we try and implement a quake-free engine using a combination of Haskell and Vulkan. So it's been a while since I did my last stream, so let's just recap where we are. So when was that? That was last Sunday, I think. Should probably be timestamped in these, but never mind. We haven't done any of these. We did more than that last Sunday. What are we today? Wednesday. Oh, well, yes, the main thing we did actually was cool. Yeah, so just demonstrate what we've got so far. Nothing too interesting, just a nice red triangle, but this is all coming from a vertex buffer now, and we've got our Vulkan device set up and everything. But what we want to change is the fact that our vertex shader just like proxies the position in the vertex buffer, which means the vertex buffer is storing normalized device coordinates when it should really be storing, I suppose, object space or world space vertices, vertex coordinates, so three-dimensional points. But of course we need to go from these three-dimensional points back to normalized device coordinates, and you would usually do that using a projection matrix. Hey Epic, Ninja Elephant, great name, just for joining. Yeah, so we're going to set up a vertex buffer object, which is the way that we're going to be able to send this projection matrix from the host to the GPU, and then we're going to have the GPU transform every vertex from the vertex buffer through this projection matrix to get it back to normalized device coordinates, and the end result will be something that looks exactly the same as it looks now, but it gives us then the opportunity to start to have proper 3D things. So we might be able to like move this matrix around and view this triangle from some different angles as we go on. Right, so how do we do this? Maybe let's start by just having a quick look at the Vulkan spec and seeing if we can find anything interesting in here. So another option that we might also look at pretty much immediately after this is something called a Vulkan push constant, which gives us a much more efficient pipeline for pushing very frequently changing values to a shader, and generally your model view projection matrix is going to change almost frame by frame as the camera moves around. So that makes sense. Already saw there, I recognise this flag bit, so it's basically saying that we're going to have to create a buffer object, and we're going to use this VK access uniform read bit to access a uniform buffer. A uniform buffer is a descriptor type associated with the buffer resource directly, described in a shader as a structure with various members that load operations. I don't really know about that latter, but that basically indicates to me that we need to create one of these as we did for our vertex buffer. So uniform, whoops. So there was quite a lot that we had to do to create this vertex buffer, which is going to be common with creating this uniform buffer. In particular, let's see, we took an array of things, and then we did peak array. It's a nice way to do this. How are we going to factor this out? Yeah, you know what? Let's avoid the refactoring for right now. actually, yeah. We'll just take a full copy and paste and see what we can factor out as we go along. Actually, you know what? Yeah, I've got a pretty good idea of what it's going to be though now. No, I'm going to do the refactoring first. Okay, I think I've got an idea of how I want to do this. So basically, when you create one of these buffers, you're going to give it, there's kind of two important things that get supplied. One is the size of the data that you're going to put in there, and the other is how you're going to put that data in there. And the two things that are kind of particular to a vertex buffer is we poke an entire array into it, and to establish the size, we have to take the length of the list and the size of a single element of the list. So those are the two things that are going to go into this this more general function, which is create buffer, and that's going to have poke and size, probably buffer type, I imagine. Let's just stick all of this down here. Change this guy to need that. It's going to be something like create buffer. So it needs the poke function. So given mem pointer. Yeah, that'll do. And takes the size. And then there was buffer type, which they call it usage, so let's go with that. Cool. So create uniform buffer. We don't have yet. Yeah. Come back to that. Okay. So yep. That goes away. Gets replaced with passing in. So this is going to need a device. And a physical device. Hey Puff and Fresh, how you doing? Cheers for joining. Yep, that's going to be poke and pointer. So now I'm going to pass that in. Yep. Put a type annotation on this. Yeah, so it's this flag mask thing. Oh, oops. Weird that GHC is a pretty strange job of inferring that type, but okay. So we factored out a way to create vertex buffers, so now it should be quite easy to create one of these uniform buffers using pretty much exactly the same thing, but our poke is going to be slightly different. Yeah, so physical device again, uniform buffer, physical device, buffer data. So now this is VK buffer usage uniform. This is just going to use poke. Okay. I'm kind of thinking, like, rather than passing in this poke function and the size function, maybe we just have like a new type wrapper around this. I think this is a good idea. Nope, storable. So the size of a is the size of element I don't really know what to do for alignment. Let's just use the alignment of its elements. You can poke. That's okay. So the problem would be we can't peek this, which we don't actually ever need to do. This is really annoying. So the storable type class in Haskell gives us a way to kind of marshal back and forth data from Haskell to C. But it's designed in such a way that it basically assumes that the data you have in Haskell can be transferred both ways across the boundary. Now, with a Haskell list, we can obviously get the length of the list, so we can poke foreign memory. But if we're just given a blob of foreign memory, we have no way of actually working out how many elements are in that thing, which is really annoying. That we're kind of forced to describe that encoding in the storable type class. And I wish that this was actually split apart into two things. One is like to C and another one is from C. And one thing we could do is, like, if you try and peek a C array from some foreign memory, we just throw an exception and say, no, you're not allowed to do that, but that's horrible. So the C array thing's not going to work. I think the correct thing is create buffer should take a poke function and it should take a size function. Yeah. Yeah, well. The reason I was thinking about this is because when we had the type of create uniform buffer, it's going to be so close to being a really general type, but there is just no sensible storable implementation that we can use. It's just such a shame that we can't replace A here with a list of vertices, but lists aren't storable, and we've just seen that, you know, it can't be done. Oh well. We could have like a create list buffer and create single buffer or something like that, but we'll worry about that later. So, quick question. So, I was wondering from what I read, Vulkan seemed only to be even more low level than OpenGL. Wouldn't this be insanely hard to write a game without graphics? Nah. Yeah, you're right. Vulkan is definitely a more complicated API, but in a sense, I actually think the complicated parts of Vulkan are going to work to our advantage in Haskell. And that's basically, well, I don't know if we're ever going to get around to this, but my gut feeling is Haskell is so far away from how you would normally want to interact with OpenGL that when you're trying to write a Haskell application that's using OpenGL, it's really difficult to get the two worlds to meet, because OpenGL wants this very imperative state-driven thing, and you're just mutating loads of state, whereas Haskell wants to be really declarative and have something else kind of take care of that. Whereas with Vulkan, because we're closer to the metal, I think we're going to be in a better situation to take a really nice declarative program and basically compile it down to a load of Vulkan stuff. And right now, we're not anywhere near that. Like right now, we're basically writing C in Haskell with some slightly better types. Can you change to an array instead? Would that be a problem? So, like, I think the fundamental problem is like the peak operation just takes a pointer. Like, you know, I mean, to recount, the type of peak is given a pointer to A, give me back an A. So, what does it mean? Like, if you give me a pointer to a list of A, and how can I work out how many things are in this list? Because the pointer itself doesn't describe anything useful. So yeah, like foreign marshal array, like we're using that here, up here, like to poke an array, and it takes a list. But the problem is, like, I wanted to, I don't know if you caught the start of the stream, but like I wanted to be able to unify these two functions together, and I can't see a way of doing that. Pure, not using the storable type class anyway, put it that way, just because peak is going to be problematic. But let's not spend too much more time on that. What is good is we might be a good part of the way there. So let's have a look. So we can now create a uniform buffer with physical device, and what's nice here is if I put a hole here, it needs some storable thing, and 4x4 matrices are storable kind of straight out the box. So what I can do, let's bring up the linear library. I could store the length, then the problem is I'd be pushing the length to the GPU and complicating my storage specification, I suppose, like the schema for the shader. And like, I don't actually care about ever reading back this data. I only ever want to push it to the GPU and just stick it over there, which is kind of why I have such a problem with the storable type class, because it assumes that I would want to read that data back, and I only ever want to push it in one direction. And I could, of course, create a new type class, but hey, I think we're kind of splitting hairs a little bit. This works for now, we'll come back to it later. So create uniform buffer, I'm going to supply a model view projection matrix. This is going to be M44, 4x4 matrix of C floats. Got there in the end. So this is going to be, we're going to transform vertices from object to world space, then from world space to view space, and then we're going to project that. And in this case, I'm going to say that the view matrix is the identity matrix. It's just identity here. The model space matrix is also the identity matrix, and our projection matrix is going to be a perspective matrix. Okay, field of view in radians. Start with 90 degrees, aspect ratio 4:3. Near plane can live at 0.1, or have a far plane at 100. Like the near and far plane don't really matter here because we're not even using a depth buffer and stuff. It sounds like we're all on the same page with the storable stuff. It's just turned into a bit of a rant from me. So once we've got those, we can then create a uniform buffer containing the model view projection matrix. So I'm kind of guessing at the moment as well. I've never used uniform buffers before. This might not actually be how you use them. I hope it is. We'll find out. We're definitely going to need this matrix anyway. I'm going to be using linear stuff a lot. I'm going to import that unqualified. Is that in here? Yeah. Cool. So, there's actually a really nice intuition you can build for working with these things as well, which I actually got from Colonel Elliott. Because traditionally when you're doing graphics programming, you're kind of forced from an early point to think about these magical matrix things. And they seem, like, certainly to me, they seem quite magical. They took vectors and they just magically put them in the right place. They move components to be in the right place. But actually, it turns out that 4x4 matrices correspond, as most people know, to a linear affine transformation. But that is actually just a general type of function. Sorry, a more specific type of function. And what I like to think, the way I like to think about this is actually that model, view, and projection are all functions here that transform a three-dimensional vector into another three-dimensional vector. So we could think of this actually being much more like projection, view, model, some vector v. And if we were to kind of read this through, this would be clear that, well, let's call this a lambda function maybe. Oh. Yeah. So model view projection takes some vertex, applies it to the model function, so that transforms it out of object space into world space, then runs it through the view function, which basically views it with a camera, and then puts the result of that through the projection matrix. And when you start to think about it in this way, it actually helps me to remember like the logical sequence that we need to multiply these matrices together. Because I mean, when I was beginning graphics programming, I might end up trying to write. Sorry, Emacs is annoying me today. Something like that. Like it's a model, view, and projection matrix, and I've just multiplied them together the wrong way. But I had no intuition as to why this would make no sense. And when you start to think about these things as functions, this says we'll take object space to world space, then project world space to device coordinates, and then view device coordinates with a camera. Like, that doesn't make any sense at that point. So anyway, let's see. How do you spell his name? That's it. I guess that one might be a good one. There's a talk on this, reimagining matrices. If you guys want to look into this a little bit more, there's not much to really go on there. But in general, yeah, have a look through Colonel Elliott's blog, because he does a much better job explaining this than me. Anyway, this is all compiling. Let's just run this through the validator and see if it's happy with everything. The next thing you've got to work out how to do is how you actually use one of these. So I guess it's going to be attached maybe to, yeah, no errors that I can see there. So I guess it's going to be attached to a render pass. Or maybe a shader module. Oh, actually, probably a render pipeline. So these go... descriptor sets, that's right. That's there. See if we can find those. Here we go. A descriptor is an opaque data structure representing a shader resource such as a buffer, buffer view, image views, blah blah blah. So descriptors are organized into descriptor sets, which are bound during command recording for use in subsequent draw commands. So, and then we have descriptor set layouts. So we've got some descriptor types. Aha, so this is, we saw this documentation before, but we need a VK descriptor type uniform buffer. It's a descriptor type associated with a buffer resource. And so I think then all we've got to do is create one of these descriptor set layouts. Have we used these anywhere? Looks like we haven't. After we create the uniform buffer, maybe let's have a look at doing one here. So let's do a managed Vulkan resource. Of course I can't tab complete that because we haven't got it yet. Descriptor set layout. That needs a device, some create info, and that's it. And there'll be a corresponding destroy. So, what do these guys look like? S type must be set to that. So 159 needs a device. P binding, this is necessary. We've got P nets and stuff first, let's get rid of those. Null, add flags to 0. Is there anything interesting here? Must not be. Okay, I don't think we're going to worry about that. It doesn't sound like anything we're doing. Okay, so binding count 1. Let's create some VK descriptor set layout binding objects. Binding is the binding number of the entry and corresponds to a resource of the same binding in the shader stages. Let's do that to binding 0. The descriptor type, it's a uniform buffer. There is going to be, I guess, one descriptor, the number of descriptors contained in this binding. If descriptor count is 0, then this binding entry is reserved and the resource must not be accessed. That doesn't sound good, so we'll definitely use 1. Stage flags. Definitely want it accessible from our vertex shader, and I don't need it visible from any other ones at the moment. Not sure what to do with this immutable samplers. I guess we're going to set that to null. It's not. So the library that we're using here is Vulkan API, and I have mixed feelings on it, to be honest. Where to start, really? I mean, I'll just bring up a random extension. No, that's not a good example because it doesn't have any function calls. Yeah, so like here we've got a create thing. Like this is the function call basically, and it requires one of these create infos. And here is the struct that you have to provide. But as you can see, it's like just a unboxed pair of pointers, I guess. And all of the actual interfacing with this is done with this camWrite field thing, which is, you can see like type level symbols here, and that gives you write field, but that doesn't take the name of the field at the value level. So there's a lot of type applications that are required. And as far as I'm aware, like the author did it this way. I don't know if you necessarily have to do it with all the fancy type level stuff, but the intention behind this library is it's meant to have zero overhead. So you don't construct a big Haskell structure to then marshal that into C, you just work directly with the underlying memory. It hasn't been too bad, to be honest. Some nice things is like they've got some custom type errors. So like if I do make a typo here at least, well, okay, it tells me that binding is necessary. Let's try it on one of the other ones. Oh, that one's not optional. Are there any of these? That one might be okay. Yeah. So like there, if I make a typo, it tells me no, it doesn't have the script account, and here are the fields that it does have. So you kind of get what you would get from the normal Haskell type checker, I suppose, in a sense. But we have, in a previous stream, had some serious problems getting this thing to like infer the correct types. So we'll see how we get on with this in the future. But we're all good there. So we've got a descriptor set. So what do we do with one of these? This looks promising. Layout is the description of binding locations used by the pipeline and descriptor sets used with the pipeline. Where's layout? BK pipeline layout. Yeah, string symbols for instances. I mean, they could have at least used like data type promotion or something like that. I would have thought that would have been better, and then we could have had the kind of all fields for KHR swap chain or something like that. So we wouldn't have to use strings everywhere. It's kind of weird that like the moment we got type level strings, everybody went crazy for them and started using them everywhere. But we don't use strings at the value level as much as we can avoid using them. So why have we suddenly started doing it at the type level? Quite strange to me. Yeah, okay, so that's not the layout we're looking for. We've got pipeline layout here. This looks quite promising, isn't it? P set layouts. Here we go. The number of descriptor sets included in the pipeline layout. So set layout count 1, P set layout. This is a descriptor set layout. I don't think we've seen that before. It'd be really nice if that was a link. they seem to be really inconsistent with as to when they want to give you a link to something. What's this big API example? The following example shows a shader snippet using 2 descriptor sets and application. Ah, perfect. So yeah, we need to do a binding. That's to be expected. Don't need to worry about the sphere V because we're writing GLSL. So the descriptor set layout binding. It's a bit bigger. Just let Chrome take its time to lay that out again. Descriptor set layout create info. So that is, yeah. So we've used that. What are these things used for? Oh no, we've used it. Ah, these are referred. Okay, so we've done all of that, yeah. Okay, so yeah, we've got everything we need. It's just this P set layouts. Let me just see if I can do this. Call that layout 0. Right, so that needs a VK descript. We need that when we create the pipeline. We don't have one of those until later. Oh, okay, we didn't need to move the buffer actually. Let's just put that back where it was for now. So we create a script set and then we pass that in, but I think they're not going to match. They do match. Okay. Basically, my confusion here is I haven't told Vulkan what the memory layout of this descriptor set is, and like I mean, for right now, we've just said that it's a 4x4 matrix of floats, which is fine because that's just laid out as a bunch of floats and contiguous memory. But if we were to put a struct in there, I usually have to say how that's laid out to the GPU, but we don't seem to need to do that at the moment, so I think we're okay. So what happens here? Now we should start getting some errors because we've said we're going to use one descriptor set, but we haven't actually bound anything. So for the vertex buff we had to do that. No, nothing has gone wrong. We haven't bound that buffer anywhere though. Ah, bind descriptor sets. What? We're in... No, we must just slightly miss that. Descriptor set layout. So we've got a descriptor set layout. Apparently we should have been querying if we could actually do that. Access to descriptor sets from a pipeline is a common show pipeline layout. Yeah, and we've done that. Ah, I don't know if we've done that. Oh, okay, we've created a pipeline layout. Once created, pipeline layouts are used as part of pipeline creation, as part of binding descriptor sets, and as part of push constants. Okay, but we're not doing that. There's some resource limits. A lot of stuff that I'm not going to read. Allocation of descriptor sets. Yeah, okay, so we haven't had to do this. A descriptor pool maintains a pool of descriptors from which descriptor sets are allocated. So I only created the layout. So I guess, yeah, if we get a descriptor pool, that's going to give me a VK allocate descriptor, I guess, or something like that. Allocate descriptor sets. And and that gives me a descriptor set. And once I have one of those, I can update it. So, where the hell did this buffer come in? I haven't had to use that anywhere. Well, there's some buffer info here. I guess it's that one. Okay. Then you need a buffer view. Jesus Christ. But then we'd finally be able to bind it. So that takes a command buffer, bind point, a layout, and some descriptor sets. Okay, so we need the descriptor pool, and then we should be able to allocate some descriptor sets. I'm going to pop over to the Vulkan tutorial and see if I've bumbled through this correctly. So, they are, yeah, creating one of these descriptor set things for the vertex shader. Null, we did that. That then lets us create a descriptor set layout, which you put into the pipeline layout. The uniform buffer apparently needs to take care of double buffering that at some point as well. Yeah, so that's what we've already done. So they create a buffer with the VK buffer usage uniform buffer. So we've done that bit as well. And to update it, I guess. Yeah, I know how to do all that. Yeah, they just map it up. Okay. So we've done everything from that. Now we just have to do this descriptable stuff. Yeah, so also someone just said this is what I'm doing is crazy. I should point out, like, it's this is not entirely new territory for me. So I've got a repository on GitHub called zero-to-quake-3, which implemented a BSP viewer using OpenGL, and that's all written in Haskell. So I could do it in OpenGL, The crazy bit is trying to do this damn thing in Vulkan, which it provides a lot of hoops to jump through. But we're close, so we need a descriptor pool. Then I get descriptor sets, so they allocate. Alright, let's plow on. So we need a descriptor pool. Let's create one of those to start with. You should be okay with just one of these. Max sets. Why is this coming out ambiguous? Ah, I didn't list rough. I only want to get one of these things, so that doesn't go here, it goes here. So with one of these I should be able to allocate why does it need a device? Like, I can't see why the device can't be tracked by the descriptor set that took a device when it was allocated. Vulkan DK allocate descriptor sets. Device allocate info and Vulkan DK free. Device pool 1. What does this alloc info look like? Okay. That was meant to be pool. Descriptor set count. And then it needs the layout. Okay, descriptor p set layout 0. Okay, yeah. This doesn't quite fit the pattern of managed Vulkan resource. Have seen it before in here. Okay, so we did manage bracket. So there's our allocate. And we need to free descriptor sets. So these are the same as command buffers and command pools, so maybe there's the potential to factor that out as well. Okay. So after we get the layout, let's get a descriptor pool. Allocate. Good, I did know correctly. So then this is going to be allocate descriptor set. This needs a device. This needs a device and a pool. And a layout. Good. Let's see if that compiles. If it does, I think we just need to update it. Once allocated, descriptor sets can be updated with a combination of write and copy operations. It's happy so far. Descriptor pool must... I don't know what that's about. We'll worry about those errors on cleanup later. Yeah, so if we're going to, maybe let's do it down here. Update descriptor set. Something like that. We're going to do vk update descriptor sets. Use the device again. Yeah, so I'd mentioned in a previous stream that I was going to look into using Rio or maybe reader T or something like that to start passing some of these common parameters around, and I'm really starting to feel the need for that now. One write count. Let's do this properly. Foreign Marshall with array write update 0 write updates. Be clear that's the pointer. Or maybe I'm going to do a copy. Descriptor sets to copy between. No, don't want to do that. God. Is there anything I can do with these things rather than just do a shitload of checks? Pnex must be null. The descriptor set to update. Got one of those. Binding within that set to update 0. Descriptor type specifying the type of each descriptor in p image. It must be the same type. Still don't know what this... array element is the starting element in that array. What array? What is that array? I'll just... No, I have to supply an int, so I'll just do 0. If I have to supply it, p text or buffer view points to an array of buffer view handles, or is ignored as described below. Only one of the members is used, and that's according to the descriptor type. Yeah. So I should actually be able to get a validation error if I null all of these. Let's see if that actually holds up. So I'm going to supply any image info, any buffer info. Oh, I might actually get a soak fault. Descriptor count. Number of descriptors to update. Alright, let's see. Seg fault, validation error, or nothing. What are we going to get? Seg fault! The worst outcome. Right, so we need a buffer info. That's buffer. Offset is 0. Range. The size in bytes. So that's really annoying. Need to do this. Like we know implicitly. That it's the size of a 4x4 matrix of floats, but like nothing in the type here says that, so we need some way to actually correctly get this information passed in. So we'll probably, I don't know, maybe need to introduce typed VK buffers or something like that. That might be a nice way of doing it. Oh, VK whole size. Use the range from offset to the end of that. Yeah, let's do that. That's better. Promising. No seg faults. Need to coerce that or cast that even. Cool, so it's just a binding now. Let's see what happens if we try and make use of this in our vertex shader without binding it. Layout, bind, what was it? It's in here somewhere. I just do binding 0. Mat 4 MVP. You're the real MVP for watching this stream. Non-opaque uniform outside of block, not allowed. Binding requires a... Okay, so I guess this has to be... Okay, yeah, it's a uniform buffer object. That's how you do it in OpenGL as well. Cool, I was happy with that. And yeah, you would access it with UBO dot. So here's the name of it. This is like, I think just a tag. Don't think that means anything in particular. That probably just got compiled away. So we're going to spec. I guess we can just MVP times position x, y, z. I think that's the correct use of homogeneous coordinates. Oh. It's going to be tricky to track down. So I think the problem here is I haven't bound it. Really hope that's all I've got to do. Take our command buffer, dk pipeline bind point graphics, pipe, I don't know what that layout is, don't know if I have that. Need a pipeline layout. Is Jutsu going to be nice enough to tell me that I've got one of those lying around? I don't think I do. Oh. I think when we created the pipeline we have to return that as well. Yeah. Somewhere down here. Okay, so there's the pipeline. And what I'm hoping we're going to get here is just a blue screen. I'm not expecting the triangle to show up because our vertices are still completely ill-specified. Okay. Now that I apparently sound like I know what I'm doing, that means all we have to do is change these vertices to be let's try positive. So where's this? Maybe let's go 1, no, 0, 1, 1, 0, minus 1, 0. So 0, 1 is going to be just at the y-axis, 1, 0 is going to be 1 on the x-axis, minus 1, 0, minus 1 on the x-axis. And I'm using 5 to be 5 units away from us. It might need to be minus 5. Okay, let's try minus 5. Fingers crossed. Still nothing. Okay. Next thing to check is maybe we need to transpose this. I don't think there is a transpose in here. I think you just use distribute. Oh, okay, we did. Transpose is just native, but a nice alias. And if that doesn't work, then we'll try putting this back to +5. And then if that doesn't work, then I'm a bit stuck. I'll have to do a bit more debugging. Alright, that's awesome. So, we're now specifying vertices in world space coordinates. It's kind of upside down as to what I'd expect. I'm going to have to get familiar with how you create the correct matrices for Vulkan. Seems that positive y points down, negative z comes out. What handed coordinate system is that? I don't know. I'll play around with my right hand and left hand coordinate system and see if I can figure out what the hell that is. Yeah, that's cool. So just to give you an idea of like what this means we can do now. So like if I change, for example, let's field of view to be pi/3. That's a wider field of view, so we would see more of the screen. So I think we should expect the triangles to kind of get smaller in the middle of the screen. If I visualize that the correct way. Yeah, so that's a small field of view. Sorry, wider field of view means we're seeing more of the screen, so therefore what we do see gets compressed. Widen that out even more. Just to double check. Perfect, so that's a really wide field of view, so that's why we can't see much there. Like the triangle's got smaller, it seems like it's further away, but it's actually because we're seeing like a very wide angle lens, which ends up having that kind of fisheye distortion as it pushes things away that are close to you. Right, a little bit of tidying up. It's actually just, we just need 2 type alias, type signatures. That line is far too long. So that one, and one more. Cool. There's no more warnings now. 1,500 lines of code just for a triangle that we can move around. What a life. Let's get the plan updated. So, what have we done today? None of what we had on our to-do list. But what we have done is introduce model projection matrix uniform buffer, which is pretty big. That's really important. That's some progress. I realise we're missing a couple of things out from here. So, like where I'm going to take this next is we need to make use of depth buffer. We haven't got any depth buffering going on yet. Text string, we're going to need that. That one actually, we can probably hold off on that. I think we can start looking at quake-free BSP. Yeah, quake-free BSPs. Not quite. There's one more thing we need before we can do that. Use an index buffer. Progress. No, that's not really correct. That's progress. So I'm just using a progress tag here to indicate like getting closer to quake-free. And I think in the next stream, probably going to look at the index buffer. That's going to be quite trivial, but then we've got all our buffer objects in place. The depth buffer won't be too much. Could be quite interesting. We'll maybe have two triangles and try and animate them moving around or something like that. Just to make sure that we've got the depth buffer correctly working. And then maybe we'll look at loading a quake-free BSP. But I'm going to wrap the stream up there anyway. Cheers for joining me today, everyone. It was a bit of a tedious one, but we had to do it at some point. It's paid off. We've got it working, and we can make some more progress in a future stream. So if you're interested in following more of this, I mostly just tweet going live announcements periodically to my Twitter page. So I'm just at Acid2 on Twitter. Follow there, and I'll just tweet whenever I'm going live. And I also tweet various other people doing graphics work, tweet Haskell stuff, and I'll also tweet links to previous streams if you missed one. So thanks for tuning in, and hope to catch you on the next one.